In this video, we're going to look at how to quantitatively analyze our electrochemistry problems. So what that means is we're going to use dimensional analysis to solve problems using numbers. So we need to know a few symbols and constants, and I believe these are given on your reference packet that you get for your exam. So the electric current is the amount of charge that passes through the area in 1 second. So we use an I for current, and that is measured in amperes. We use Q for charge, which is coulombs, and then of course time is our T in seconds. Now Faraday's constant is 96,500 coulombs per mole of electron. And on your reference materials, they give you, it's like 96,400 and something, but we round it to 96,500 just to make our math a little easier here. Alright, so a question that we might have would look like this. How much charge passes through the cross-section of a wire carrying 0.987 amps of current for 12.3 minutes, and how many moles of electrons pass through that cross-section? So what are we going to write down first? In our first problem, we want to know how much charge is passing through our wire. So the charge is measured in coulombs. Okay, so we're going to have to work our way to coulombs in our dimensional analysis. So if we start with the minutes that they give us in the problem, we can convert that to seconds. And then we know that our charge is 0.987 amps. 1 amp is a coulomb per second if we go back and rearrange our equation. So we can cancel our seconds and we end up with 728 coulombs. Now for the second part, we want to know the moles of electrons. So we use our answer in part A with coulombs, and remember that a coulomb is Faraday's constant per mole, so we can, Faraday's constant is 96,500 coulombs per mole. So we can use that to calculate 7.54 times 10 to the minus 3 moles of electrons. Now we can also use our quantitative analysis to solve problems like this, where we can determine how long, we can determine times, we can determine quantities, we can use stoichiometry to calculate volumes in a metal refinement process. So a typical problem might look like this. How long would it take to plate out 3.56 grams of silver from a solution that contains silver ions when a current of 2.5 amps is applied? So we are going to use our dimensional analysis, and we need to get from grams of silver to time. How long would it take? So we want to get to seconds. Unless they tell us, you know, some other time they want us to find. So if we start with our grams of silver, then we can change that to moles using our molar mass. Okay, so there's 1 mole of electrons for every mole of silver, because your cation is going to accept 1 electron to, your Ag plus is going to accept 1 electron to become Ag solid. If we wrote out the half reaction for there, it would be 1 mole of electrons. Now if your cation had a +2 charge, like if we had calcium or iron 2 or nickel 2 or something like that, then we would use 2 moles of electrons there. So then our next step, we would use our Faraday's constant in coulombs per moles of electrons, and then we would use our amps, which remember an amp is a coulomb per second. Now in this case, this problem changes minutes to or seconds to minutes, although it doesn't really say to do that. They did it anyway. So if they don't say anything about time, usually they'll tell you, time in seconds or minutes, and then you can figure it out. So our answer here is 21 minutes. Another problem might look like this. If we have 2 Faradays of charge pass through a silver nitrate solution, what mass of silver is plated out? Now, excuse me, what do you think is meant by 2 Faradays of charge? Alright, what that means is that, excuse me, we have 2 times our Faraday's constant. Alright, so we set up our equation, and it's going to look like this. So basically we have 2 moles of electrons here. So we know that each mole of silver ion is going to have 1 mole of electrons. And we know that the molar mass of silver is 107.87 grams. So they did ask us for mass, and that's what we have found here. Typically we see this kind of question in a multiple choice part, but that doesn't mean it won't appear in the free response. So, that's a good place where we'd use 96,500. And notice that that cancels. So you actually end up just multiplying the 2 in your conversion here. So we will do more practice problems with these.